Hello again, this is Jeff Scott, your instructor for the online version of 152-163 Relational Database Design for the fall 2015 semester at Blackhawk Technical College. I'm going to be coming at you right now with the last two lectures for the class, and they're not out of the book, just so you know that. There will be one assignment based on those, and I will explain that in the second lecture. During the summer, near the beginning, well, probably around mid-July, I was contacted by a company in the Beloit area that was interested in knowing about the graduates and the type of experience the graduates had designing databases. And although we have a class, this class, that's called Relational Database Design, we really don't go through a lot of design in here. So we're going to talk a little bit about that now. And let me just mention to you, if you remember when we started to go through the whole spiel with this, that we talked about, we had an employees table here. And each employee had an ID number, which was the employee's primary key. Each employee had a first name. Each employee had a last name. And each employee worked for a department. But one of the things that we mention in here is not the ID, not the first name, not the last name, but the department, and this wasn't department number, this was originally, if you remember, this was department name. The department name is actually duplicated. IT is in here 1, 2, 3, 4, 5 times. Payroll is in here 1, 2, 3, 4, 5 times. And accounting is in here 1, 2 times. Now that might not seem like a lot, and it really isn't that big of a waste of space. But once you start talking about putting hundreds, thousands, tens of thousands, millions of records into a database, what you're going to end up doing is wasting a lot of space by having all this information repeat. And there's redundant information in here. What if someone who's putting in the information for accounting sometime does this? And they abbreviate accounting ACCTING. What if somebody actually writes in here information technology, but the next person comes in and they type in info technology? All right. What this can lead to are what are referred to as anomalies. So situations where you have data that should be the same and is not the same. So how did we fix this? We went through and we changed it, so instead of having one table, an employees table, we now have two tables. All right, and one of those tables represented or had the still the employee ID, just like we had before, the employee's first name, the employee last name. But rather than having the employee's department name in here, we just put in their department number. And then in a separate table, we put in that number, which was a primary key in there, and then the actual name. What's the advantage of this? The biggest advantage is the fact that the department name is only in one table, and in that one table, each department name is only in there one time. What I'm starting to show you right here is a topic that, for lack of better words, goes by different names. All right, but I wanted to show you, let's see where I have it. I hope I still have it open here. I know where it is. And it's the topic of database normalization. All right, now they mention in here, and this is a 4-part series, and I've saved all 4 parts into 4 different Word documents. But notice, normalization is the process of efficiently organizing data in a database. Normally what it involves is taking, a lot of times in the quote olden days unquote, when somebody created a database, what they ended up doing was they had what was called a flat file. In other words, they had one table that had all their information in it. It's not a really good way to do things. By normalizing a database, as it says here, we have 2 goals. One is we want to eliminate redundant data. And I showed you an example of that going between here and here. All Alright, so that's the first thing we want to do, is eliminate redundant data. We also want to ensure that any data dependencies that are in there make sense. Alright, so we don't have things in a table that really don't belong in a table. Alright, now in this article they talk about the normal forms, and there literally are about 7 or 8 normal forms that you can have with a database. This particular article here talks a little bit about 1NF, which is first normal form, 2NF, which is second normal form, 3NF, third normal form, and one that's called BCNF, or Boyce-Codd normal form. Alright? These are guidelines, as is mentioned in here. So sometimes you have to stray from these guidelines, especially if you've got a very small database. Alright? But I want to talk to you just a little bit about what first normal form, second normal form, third normal form are. I don't really care about Boyce-Codd normal form and fourth normal form, although they're listed in this article. Alright. First normal form sets very basic rules for an organized database. Eliminate duplicative columns. We already did that. Create separate tables for each group of related data and identify each row with a unique column or set of columns. So in other words, when we came in here and we converted this into this, we were putting our database into 1NF, or first normal form. Second normal form assumes that you're already in first normal form, and you remove subsets of data that apply to multiple rows of a table and you place them in separate tables. And you create relationships between these new tables and their predecessors through the use of foreign keys. Again, you could even make a case and say that when we went from here to here, we're putting it into 2NF, because now we have that field in here, so we're able to relate that table with this table. Alright? And then finally, when you talk third normal form, you remove any column that's not dependent upon a primary key. Now, I don't expect that to make a whole boatload of sense to you. I would recommend that you take a look at that. I've also found this online under the Microsoft Developer Network, Access Database Design and Programming 2nd edition. And it's a little longer thing, and it also explains first normal form, second normal form, etc. And I also put that one into a Word document. It's about 16 pages long. So again, I'm more concerned that you understand the stuff that's shown in there, what redundancy is, what normal forms are, what 1NF or first normal form is, really what a functional dependency is, because it moves us into second normal form or 2NF, and what 3NF or third normal form is. Alright, so just mention this to you again. I'm not going to go over 4NF with you, and I'm not going to go over Boyce-Codd normal form with you. Alright, so let's talk about first normal form. As it says, first normal form, or 1NF, sets very basic rules for an organized database. So first, you want to eliminate duplicative columns from the same table by creating separate tables for each group of related data. Now, they give some examples in here, but what they're saying is what you want is the atomicity of a table. So if you have tables that comply with 1NF, they're said to be atomic tables. Now, unfortunately, the example that they give in here isn't very good, so I don't want to go over it. I think the example I used with you is better than the one that's in this article. Alright, when you go from first normal form into second normal form, first of all, to be in second normal form, you must already be in first normal form. You want to remove subsets of data that apply to multiple rows of a table, and you want to place them into separate tables and create relationships between these, again, through the use of primary keys. So if you look in here, here's an example that they give. and they say you might have a table, one single table called customer, and that table may have all of that information: a customer number, a customer name, an address, a city, a state, and a zip. But when you think about it, it's totally plausible that this information that's in here, the city, state, and zip, could be duplicated hundreds, thousands, millions of times. And what you have and again, if you go back and look at this article that I mentioned to you when they talk about functional dependencies, in many ways, the zip code functionally determines the city and state. If I say 53547, you should be able to tell that it's Janesville, Wisconsin. So what we do is we take these tables here, or those four fields and this field, and we put them into one table. Then we create a second table that has the zip, the city, and the state. So the zips are going to be in there multiple times, all right? But the master zip table, each zip code will only be in once, each city will only be in once, and the states, unfortunately, will be in there multiple times. Actually, it's possible cities could be in there multiple times also, because many cities have more than one zip code. They mentioned there if you wanted to be very efficient, you could fill that table in advance. The post office provides a directory of all valid zip codes that exist in the country. So this is what you'd have: custom, first name, last name, address, zip, and another table with zip, city, and state. Okay. Finally, to get into third normal form. And again, as I mentioned, you might want to go back and look at this article, and you will have all of these at your disposal, because it gives you this in a little bit more depth and breadth of coverage. Okay? So finally, for third normal form, you must already be in second normal form, which means you must already be in first normal form. Remove columns that are not fully dependent upon the primary key. So let's look at the example they have here. You've got a table, and it has in there order number, customer number, unit price, quantity, and total. Well, one thing about this, first of all, this field is total is what's referred to as a calculated field. Total is not even needed in this table. Total is unit price times quantity. Since it's a calculated field, you are best off, rather than putting that in the database, just calculating it by putting this in here. All right? Because as the unit price changes, or as the quantity changes, so will the total. Many books will tell you you should never put a person's age into a database. Rather, you put in their date of birth, because you can always figure out their date of birth, or their age rather, by taking their date of birth and subtracting from it, all right, or really I guess the reverse, taking the current date and subtracting from it their date of birth. So the author says, well, what if we come in here and instead of having all this information, what if we come in here and just put in this? And in this case, all right, in this case, you're in 3NF. Now the key thing to realize here, not only is that a calculated field, but technically the total isn't dependent on the order number. The total is dependent upon unit price and quantity. So you've got a non-primary key field that's dependent upon two other non-primary key fields. All right? So this field definitely should not be in your table. Now, that was very quick. Again, I'd strongly suggest that you go back and you take a look at this. Access, database, and programming. Again, if I come in here and I Google and I put in database normalization, 1,990,000 hits. You can see amongst others the basics rather of database normalization. Description of database normalization basics. This is again from Microsoft. All right. So they've got more examples in here. There are just example after example after example. So what does this have to do with anything? I'll give you that in the next lecture.